Hello, fellow space explorers. Today we're diving into one of the most exhilarating concepts in science fiction and theoretical physics: warp drives. Have you ever gazed up at the stars and wondered how we might travel faster than light? Buckle up, because we're about to break down the science behind warp drives, explore how they might work, and discuss the steps we need to take to reach this groundbreaking technology. First things first, what exactly is a warp drive? You might recognize it from shows like Star Trek, where it's portrayed as a futuristic propulsion system that allows a spacecraft to travel faster than light by bending space-time itself. But here's the twist. It doesn't technically move the ship faster than light. Instead, it warps or compresses space in front of the ship and expands space behind it, allowing the ship to ride this bubble of space-time. Imagine surfing a cosmic wave, where the wave is the fabric of space itself. Now let's get into the nitty-gritty of the science. The idea of a warp drive was first proposed by theoretical physicist Miguel Alcubierre in 1994. According to his theory, the ship doesn't break Einstein's laws of physics, specifically the speed of light limit, because the ship itself isn't technically moving. Instead, it manipulates the space around. It's like having a magic carpet that doesn't fly, but rather rolls up the ground beneath it. In Einstein's theory of general relativity, space and time are intertwined and can be warped by mass and energy. Alcubierre's warp drive concept takes advantage of this. By creating a warp bubble, the spacecraft could shorten the distance between 2 points by compressing space in front of it and expanding space behind it. This way, the spacecraft appears to travel faster than light without violating relativity. It's a brilliant workaround that keeps Einstein smiling in his grave. So, if warp drives are theoretically possible, why aren't we building them yet? Well, the biggest hurdle is the energy requirement. According to Alcubierre's calculations, the amount of energy needed to create a warp bubble would be astronomical. Initial estimates suggested it might require as much energy as is contained in an entire star. Yes, you heard that right. An entire star. Some researchers have even estimated that it would take about 1045 joules, which is many times the total energy output of the sun over its entire lifetime. Talk about a tall order. However, there's a silver lining. More recent research by scientists like Harold Sunny White at NASA has explored ways to reduce those energy requirements. His work suggests that by tweaking the geometry of the warp bubble, we might be able to bring down the energy needs to something more manageable, though still incredibly challenging. It's like trying to fit a square peg into a round hole, but with a few clever adjustments. Now just imagine flying through the cosmos at warp speed. To an outside observer, your ship might appear to vanish as space-time bends around. Inside the ship, however, you wouldn't feel the speed. You'd simply see the universe compressing and expanding around you as you travel vast distances in the blink of an eye. It's a mind-bending thought, isn't it? This could allow humanity to travel to distant stars galaxies in just days or weeks, rather than centuries or millennia. Warp drives could make interstellar exploration and colonization a reality. So how do we get there? Warp drives remain a distant goal, but there are steps we can take to move closer to achieving this incredible feat of engineering. First, we need to figure out how to create and control exotic matter and negative energy. Essential ingredients for creating a warp bubble. Exotic matter has properties that are the opposite of normal matter, such as negative mass or negative energy. While we haven't observed these directly yet, quantum physics has shown that negative energy does exist in small amounts, such as in the Casimir effect. In the Casimir effect, two closely spaced metal plates in a vacuum can generate negative energy between them due to quantum fluctuations. Understanding and scaling this effect might help us unlock the key to generating the negative energy needed for warp travel. It's like finding a hidden treasure chest in the vast ocean of quantum mechanics. NASA researchers are working on cutting-edge propulsion technologies that could one day lead to warp drives. The Eagleworks lab, led by Harold White, has been investigating potential ways to manipulate space-time on a small scale. In 2021, White and his team published a study suggesting that small, naturally occurring warp bubbles may already exist on quantum scale, giving us a glimpse of what's possible. If we can manipulate these bubbles, we might one day create a full-scale warp drive. It's like discovering a tiny portal to another dimension. One promising area of research is quantum field theory. Some physicists speculate that by manipulating the quantum fields that permeate all of space, we could effectively create a warp bubble. This could involve using intense magnetic fields or plasma to interact with the quantum vacuum and generate the energy needed for warp travel. While warp drive technology remains speculative, each new discovery brings us one step closer. As our understanding of quantum mechanics, exotic matter, and space-time grows, so does the possibility of one day achieving faster than light travel. So, can we reach warp drive? The answer is maybe. With advancements in technology and physics, what was once the realm of science fiction could become science fact. We're still in the early stages, but who knows? Perhaps in the next century, humanity will break the light speed barrier and explore the stars. One thing's for sure, warp drives ignite our imagination, and the quest to travel faster than light will continue to push the boundaries of science and technology. If you're fascinated by this cosmic concept, make sure to subscribe for more videos about space, science, and the future of exploration.